Check the solutions for your previous assignment. First main, write all the factors of the following numbers. Question number A, 9. So if you factorize 9, you can write 9 ones are 9 and 3 threes are 9. So 1 into 9 and 3 into 3. So the factors of 9 are 1, 3 and 9. Question number B, it was 13. So 13 is a prime number. So if you factorize, you will get 1 13s are. So the factors are 1 and 13. Question number C, it was 20. So 1 20s are 20, 2 10s are 20, 4 5s are 20. You can think of like 5 4s are, it is same as 4 5s are. Again 10 2s are, it is same as 2 10s are. So we are not repeating. Even 20 1s are also. So the factors of 20 are 1, 2, 4, 5, 10, 20. Question number D, it was 26. So if you factorize, you will get 1 26 are 26, 2 13s are 26. If you try with any other number, you will not get any other factors also. So the factors of 26 are 1, 2, 13 and 26. Next question E, 40. If you factorize 40, you will get 1 40s are 40, 2 20s are 40, 4 10s are 40, 5 8s are 40. So the factors of 40 are 1, 2, 4, 5, 8, 10, 20 and 40. Next main, fill in the blanks. Please check your answers. Question number 1. The least prime number is 2. Question number 2. 1 is a factor of every number. Question number 3. 1 is neither a prime nor a composite number. Question number 4. When a number divides another number exactly, then the divisor is called a factor. The first perfect number is 6. I hope you all have done. Let's have a quick recap of our previous class. In the last class, I have discussed about factors. So can you remember what does it mean by a factor? A factor is a number that divides another number exactly without leaving a remainder. I have discussed about the properties also. So the first property I told as 1 is the factor of every number. Point number 2, every number is the factor of itself. Point number 3, every factor is less than or equal to the given number. And the last point I told, there are finite number of factors. We have discussed about prime numbers and composite numbers also. So what is a prime number? A counting number other than 1 is a prime number if it has no factors other than 1 and the number itself. Few examples also you have seen. So these are like 2, 3, 5, 7, 11, 13, 17, 19, etc. So if we think about composite numbers, you can remember also that counting numbers other than 1 which are not prime are composite numbers. Composite numbers have at least one factor other than 1 and the number itself. So examples we have seen like 4, 6, 8, 9, 10, 12, 14, 15, 20, etc. So these are the things we have discussed in our previous class. So let's start today's lesson. In the last class, I have discussed about perfect number. I showed you that 6 is the first perfect number and I asked you what will be the next perfect number. Have you tried? If you have tried, you can check here. The next perfect number is 28. So if you factorize 28, what you will get? 1 28s are. So 1 into 28 gives you 28. 2 into 14 gives you 28. 4 into 7 gives you 28. So the factors of 28 What are those? 1, 2, 4, 7, 14 and 28. So what you have to do? You have to find out the sum of the factors. So here you can see the sum of the factors are 1 plus 2 plus 4 plus 7 plus 14 plus 28. And the sum is 56. What we have discussed about the perfect number, that if the sum of the factors of that number is twice the number, then only we can tell that number is a perfect number. We can call that number as a perfect number. So here the sum of the factor is 56. So 56 is twice of 28. That's why 28 is a perfect number. So the second perfect number is 28. I hope you have enjoyed. Today we will start our lesson with factor tree. So what is factor tree? Factor you already know. We will factorize a number and the presentation will look like a tree. Because tree has branches, when we will factorize a number, it will also have some branches. Okay? So it is nothing but a diagram. So our diagram will look like a tree. That's why we call it as factor tree. So for what we will use? We will find out the factors of a number and the method is known as factor tree. Basically, when we use factor tree, so the factors comes in terms of prime numbers. You already know what is prime numbers. I have explained also. So as we will work out, it will be much more clear to you. So when we will use factor trees, there are so many ways you can factorize also. So let's check what is factor tree. So factor tree is a tool that breaks down any number into its prime factors, means into its prime numbers. You will factorize and the factors will be in terms of prime numbers. It can be represented diagrammatically. So through diagram we can represent. And factor tree can be written in different ways by taking different factors. For example, if I say 6, so the factors of 6 are 1 6 are 6. So 1 into 6 gives you 6. Again, 2 3s are 6, means 2 into 3 gives you also 6. So there are different ways. You can take anything and go ahead. So we will work, it will be much more clear to you. Now we will work out few sums using factor tree. Here I have written one number 24. You please write down in your notebook. You can circle the number using your pencil. Next step, what you have to do is split the number 24 into two numbers. How? You have to find a pair of factors of 24. If you think where you get 24 as a product of two numbers, suppose 2. So 2 12s are 24. Yes. So we can think that 2 and 12 as a factor of 24 and we will split 24 with those two numbers. Okay. For that reason, what you have to do, just draw two arrows from 24. Here I am drawing, you please work with me. And at the end of the arrow, you can write 2 and 12. You can draw a circle with your pencil. So here 2 and 12, these two factors will form the first branch of your factor tree. Now you look at 2. 2 is a prime number, so we cannot factorize, but 12, as it is a composite number, we can break it again into a pair of factors. Okay. So how we will break 12? We can do it as
2 6 are. So from 12 you take another 2 arrows. So here the next branches. So I told you as 2 6 are. So please do it. So here these 2 is a prime number. We are not going to factorize, but 6 is a composite number. We can split it. So we can split it as how? 2 3s are. So draw another 2 arrows from 6. And end of the arrows you can write 2 3s are. Can we do further? No, because 2 and 3 both came in prime numbers. So here this red color 2, these 2 and these 2 and here these 3 all are in prime numbers. Okay. Now you can ask one question. This 12, why I have taken as 2 6 are? Can't we take as 3 4s are? Yes, you can take it as 3 4s are. Same the way 24 also we can take in different ways. So factor tree, when we are doing, we can split the number in different ways. There are so many options. You can choose any one. It doesn't matter, but finally the final factors will be same. How? You just multiply these numbers, means here 2, these 2, this red color, one more 2 and 3. If you multiply, the product will be 24. Okay. We will do all the ways. I will show you that how we can do the factor tree in different ways. So what I wanted to mean that you can pick any 2 factors and carry on your factor tree. But the end result will be the same, no matter which ones you have start with. Okay. So finally, we can write that 24 equals to 2 into 2 into 2 into 3. Okay. I hope you are clear. Now we will break down 24 taking another pair of factors. So we have done in the previous sum as 2 12s are. So what can we go for? We can go for 3 8s are. Yes, as we are using the factor tree method. So what we have to do? First, you write down 24, draw a circle using your pencil. Then you draw 2 arrows from 24. This is the first branch for this factor tree. So please write down taking a pair of factors as 3 and 8. So please work out with me. You can see here 3 is a prime number. So what we will do? As 8 is a composite number, we can split it. Can you tell me how we will break down 8 into a pair of factors? We can do it as 2 4s are. So another branch will come from 8. So draw another 2 arrows from 8. Now end of the arrows, you will write 2 and 4. Here the 2 in red is a prime number. So we are not going to factorize, but we will factorize 4 because 4 is a composite number. So we can break it or split it as 2 2s are 4. So please do it. I hope everybody is working with me. So it is 2 2s are 4. Now all the numbers read in prime numbers. And we are not going to break anymore because these 2 are in also prime. And if you multiply this 2, 2, 2, 3 2s along with 1 3, you will get back 24. Yes. So your factor tree is over here. Finally, you can write that 24 equals to 2 into 2 into 2 into 3. So what you have got in a previous way, taking the factors as 2 into 12, here we have done as 3 into 8. It doesn't matter, but the final answer is same. Yes? Now we have one more option to split 24 into a pair of factors. Can you guess? Yes, you are very much correct. It is 6 fours. So please do it. So if you have worked this much, then you can find out that 4 is a composite number and 6 is also a composite number. So first we will split 4 into a pair of factors. So what are those? It is 2 twos are 4. So we will draw another 2 arrows. End of the arrows we'll write 2 and one more 2. Now look at 6. So we will break 6 as 2 threes. Yes. Please work out in your page. You can break or you can split the number till you reach in prime numbers. So here you can see 2, 2, 2 and 3 all in prime numbers. So your factor tree is over. You can write down finally 24 equals to 2 into 2 into 2 into 3. If you multiply, you will get back 24. So I hope you are very much clear with the factor tree method. The 24 we have broke down in different ways. I mean taking different factors. But finally we got everywhere 3 2's along with 1 3. And you have multiplied and showed also the product is 24. Let's work out one more sum. Take the number 18. Draw a circle around the number using your pencil. Now you will break 18 into a pair of factors. So try with a minimum number. So can we go for 2 nines? Okay, please try. So what you have to do? Draw 2 arrows. Write 2 nines. Now 2 is a prime number. We are not going to factorize, but 9 is a composite number. So we will split it as 3 threes. Yes? So please carry on. So draw another 2 arrows and write down 3 threes. So you can see there that 2, 3 and 3 all are in prime numbers. So your factor tree is over. Finally what we can write? We can write 18 equals to 2 into 3 into 3. So I hope you have enjoyed factor tree. Now I have a question here. Can we do or can we factorize 18 taking any other pair of factors? Yes, we can do 3 6. Yes. So please carry on. Now draw the factor tree for 18 taking factors as 3 6. Yes. So please carry on. So draw 2 arrows from 18. End of the arrows you write 3 and 6. 3 is a prime number, so we are not going to factorize, but 6 is a composite number. We can break it. We can split it into 3 6. So another 2 arrows. So end of the branches you can write 2 and 3. So here 3, 2 and 3 all in prime numbers. So your factor tree is over. Finally you can write down 18 equals to 2 into 3 into 3. If you multiply you will get back 18. I hope you all have completed also.
Complete the factor tree by writing the missing numbers. So look at the factor tree here. You can see some of the places are empty and some of the places are filled with numbers. So first you copy the factor tree. Where it is empty, keep it empty. Where it is filled with numbers, fill with the number given here. And then try to solve it. But from where you will start? Look on the top, the number is given as 48. So you have to split 48 into two parts. Yes, I mean a pair of factors. How? One is 12, the other one should be what? If you go for table 12, 12 ones are, 12 twos are, 12 threes are, 12 fours are. 12 fours are is how much? 12 fours are it is 48. So we can place it here 4. Okay. So the first part you can write it there as 4. So it is clear that 12 fours are 48. Now come to the next step. So if you look at 12, from 12 the branches are, one is 3 and the other one it is empty. So to get back 12, what do you need to place here? So 3 fours are 12, is it? So we can place it 4 here. So please do it. So 4 threes are 12. So this empty place has been filled with 4. Now you come to here, means next to 2. So 2 is here. One more blank space you can see here. You have to multiply 2 with something and get back as 4. So 2 twos are 4. Yes. So place 2 there. So here it is 2. There is also 2. So this part is over. Come back here. 4 has been divided into two parts. One is 2. The other one should be how much? 2 twos are 4. So there will be 2. So all the empty spaces has been filled with the numbers. So it is nothing but a factor tree where some places were empty and you have filled it. I hope you are clear. Now look at this factor tree here. You can see down all the numbers are given. As you go up, you can see the empty places. So you have to find out these missing numbers and you know down the numbers. How we will start from here? Start from one end. So here you can see 2 and 3. So if you multiply 2 and 3, you will get back this number. So 2 threes are how much? 6. So just try. 2 threes are 6. We'll write it here. Yes. Now you go here 2 and 5. So 2 fives are how much? 10. So these two places you solved it. Now if you multiply 6 and 10, you will get back the number on the top. So 6 and 10 gives you as 60. So all the empty places has been filled now. So you have solved it. It's very easy. Observe the table here. 1 into 12 gives you 12. 2 into 6 gives you 12. 3 into 4 gives you 12. So if I ask you what are the factors of 12, you can easily tell that 1, 2, 3, 4, 6, 12 are the factors of 12. Yes, because you have worked a few sums on factors. Now I want to ask you one question. Look at the question here. What is 12 called with respect to 1, 2, 3, 4, 5, 6 and 12? I'll make it clear to you. Here you can see you are multiplying two numbers and you are getting the product as 12. Yes. So whatever the pairs you are multiplying, all those are factors of 12. Now the question is, on the right side you are getting the product everywhere as 12. So does this 12 have any name, or what we can call it? So that's why the question I have asked you, what is 12 called with respect to 1, 2, 3, 4, 6 and 12? Means with respect to those factors. Okay? Actually, 12 is called the multiple of 1, 2, 3, 4, 6 and 12. What I told? 12 is called the multiple of 1, 2, 3, 4, 6 and 12. Why we are calling 12 as multiple? Because we are taking two numbers, maybe 1 and 12 or 2 and 6 or 3 and 4. We are multiplying both these numbers and getting 12 as a product. Multiple is nothing but the product of two or more numbers. So what is multiple? Multiple is the product result of one number multiplied to another number. I hope you are clear. Look at the examples here. I have taken 1 multiplied with 1, so the product is also 1. Now I have taken 2 multiplied with 1 and got the product as 2. Here 5 into 1, 5 has been multiplied with 1, you got the product as 5. One more example here, 9 into 1 gave us the product as 9. I have taken 11, so 11 into 1 equals to 11. I have taken one more, that is 95, has been multiplied with 1, gave as the product 95. So here you can see that we have taken different numbers like 1, 2, 5, here 9, 11, 95. They all have been multiplied with number 1. And if you look at the product, you can see we got back the number itself. 1 multiplied with 1, we got as product 1. When 2 has been multiplied with 1, you got back the number itself. 5 multiplied with 1, we got back 5 only. Even you can see for 9, 11 and 95, all the numbers here multiplied with 1 and we got back product as the number itself. Yes? So, what can we say after looking at these examples? We can say that every number is a multiple of itself. What I told? Every number is a multiple of itself. There are different numbers we have taken. Okay? And the product we got the number itself. That means every number, whatever number you are taking, the number is the multiple of the number itself. Okay? Observe the following examples here. I have taken different numbers and I have been multiplied with 1. Look at the first one. 1 into 1 equals to 1. 1 into 2 equals to 2. 1 into 5 equals to 5. 1 into 10 equals to 10. 1 into 115 equals to 115. After observing these examples, what you can say? If you take any number and multiply with 1, so we can say that 1 is a multiple of 1. If we look at the first example. Second example, you can see 2 is a multiple of 1 because the product you see. We have seen the definition of multiple is if you multiply one number with the other number, the product is the multiple. Yes? So here you can say that 5 is a multiple of 1. Same the way we can say 10 is a multiple of 1. Like that, 115 also is a multiple of 1. So we can conclude that every number is a multiple of 1. Now we will list the multiples of 7. So how will you do? You will do like 7 ones are how much, 7 twos are how much, 7 threes are how much. So if you think of the multiplication table of 7, you will get the product, and those products are the multiples of 7. So please try. You will write down in your notebook. I hope you all can do. Here I have written few multiples of 7. 7 ones are 7, 7 twos are 14, 7 threes are 21, 7 fours are 28, 7 fives are 35. I didn't write more because this is how much I can write. Can you tell me what is the last multiple? What is the last multiple of 7? Is there any end? No, there is no end till how much you can count. It is endless. Because if you think the multiplication table of 7, it is 7 tens are 70. But after that also it is there. 7 11s are, 7 12s are, 7 13s are, till how much you can go. If you keep on counting, you will get multiples. Yes? So there is one important point here, that there is infinite number of multiples for every number. If you look at the multiples of 7, you can see it starts with 7, then it is increasing. As it goes on, it will increase. So can you tell me what is the smallest multiple of 7? You can see the first one, 7 ones are 7. That is the smallest multiple of 7. Because after that, it is increasing, increasing and increasing. Okay? So the multiples of any number, it is equals to the number or greater than the number. Okay? So here I have discussed two important points. So the first point is multiples are greater than or equal to the number. You have seen here. As for example, I have taken the number 7. You can try with any number and you can find out that all the multiples what you are getting, they are either equal to the number or greater than the number. Okay? And the next point I told you already, there can be infinite number of multiples, because if you multiply any number, here I have taken 7, I have multiplied with 1, 2, 3, 4, 5, you can do it 6, 7, 8, 9, 10 till how much you can count. So the multiples what you are going to get, that is limitless. So that's why there can be infinite number of multiples. So these two are very important point, properties of multiples. Now as a whole, you look at the properties of multiples. So I have discussed already. The first point is every number is a multiple of itself. Second point, every number is a multiple of 1. Third point, multiples are greater than or equal to the number. And the fourth point, there can be infinite number of multiples. You please note these properties, these are very important. Write down this sum. Write first 5 multiples of 14. It is first 5 multiples, so you have to start from 14 ones are. So please write 14 ones are 14. Next 14 twos are. Write off 14 twos are 28. Next 14 threes are 42. Next 14 fours are 56. Then 14 fives are 70. You should be very much thorough, because you have to find out multiples, so very much thorough with the multiplication tables. So you can write down the answer. The first 5 multiples of 14 are 14, 28, 42, 56 and 70. Look at the assignment. First min, write the factor tree for the following numbers. A 20, B 32, C 45. Today we have worked out so many sums on factor tree. I hope you all can do. You take any two factors and carry on your factor tree. Second min, write the first 5 multiples of the following numbers. Take the numbers as 17. Find out the first 5 multiples. I have worked out one sum like this. B is 23 and C is 9. Please try all those. Third min, complete the factor tree by writing the missing numbers. So it is given here 36, here 4, here 3. The rest of the places are empty. So please try. This is very much interesting. We have worked out sums like this also. Please do it. I know you all can do. Thank you.